All right, I'm recording this on Monday, September 11th, good old 9/11, on 2017. But anyway, I'm doing that so that because I'm probably going to, for just for your edification, I am probably going to copy this course over for semesters to come because I'm doing a lot of uh, fun work here, rebuilding this course and making it a little more. I'll be honest with you. You guys are taking a pretty accelerated course here. I mean, I teach physics 210, and what you're doing is I would call, you know, this course is supposed to be physics 130. I would say this is like physics 200.5. But you're not having to take it. You're not having to come in and take an exam with just one page of formulas and then figure things out. But you could do it, and I think you're learning a lot of good physics too. But anyway, so let's look at the assignment number 3 that I have posted, because I got some crazy stuff on there that I'm going to work out with you, and I want you to kind of go through. I won't give you the answer, but I'll show you how to work out the answer so that you can have fun with it. So be warned, this is a little bit tricky. So if you started this like you go, man, it's going to be doing an hour. Eh, should have started sooner. Of course, I'll tell you to do that anyway. All right, it's a pretty good. Had a pretty good weekend. I mean, I feel for those of you probably. I mean, all of us have family in between. I mean, between Corpus Christi and Miami or Orlando, Florida. That's a pretty big chunk of the United States is getting battered by hurricanes right now. But so I'm hoping that if you if you have family in that area, that everything is working out as best as can be. Like they're alive and healthy and safe, and then we'll let the insurance companies work it out. But anyway, um, the Royals are still alive. They're 5 games from elimination, completely eliminated by the Indians from making it to the play, from winning the division. But that's never going to happen anyway. But they're still kind of hanging in there. They're only 2.5 games behind the Twins, who have the last wild card spot in the playoffs. Of course, there's about 3 teams ahead of them that are a half game out or 1.5 games out, and so they're going to keep winning too. So it's going to be a real dogfight. It's going to be tough for the Royals. Like right now, the prognosticators are saying they got about a 4% chance of making the playoffs. That was about my chance I gave them at the beginning of the season. It was my chance I gave them 2 seasons ago when they in the off season when they signed. And I hate to crack on the guy all the time, but when they signed Alex Gordon to a $72 million contract, I was like, that makes no sense whatsoever. Now they got a steal with Salvi, and if you want a kind of I don't know, an eye opener, you can go to the Royal salaries and see if there's a color line there. If you can, if such a thing exists. In, I mean, sure, Lorenzo Kane makes an extraordinary amount of money compared to us, but compared to Danny Duffy, compared to Alex Gordon, compared to some of the other players that don't contribute near as much as Locaine does, I don't know. And none of the Royals are as valuable as Salvador Perez. He's just incredibly hurt right now, and that's why he's slowed down a little bit. But it's a real eye opener. Anyway, so without further ado, I'll get off my um, racial inequity soapbox here, because it even happens at where you think, well, they're all getting. No, you take a good look at the salaries, and it's about double. All right. So anyway, enough of that. Didn't mean to be such a Debbie Downer there, but anyway. But I think it's important that we look at these issues, even because everything's relative. All right. So Wow, look at all the work we've done so far. All right, so let's take a look at this exercise 3. Okay, let's begin. Let's begin this thing. All right, so here you go. Some of you are going to get a chance to redeem yourself here. If you lift a 20 kilogram weight, 2 meters high, how much work did you do? Don't forget gravity, okay? Force times distance. The force is the weight, which is mg. All right, so what does that look like? Let's do the equation for, for assignment 3, let's do equation 1 here. Exercise 3. I don't know why I went on so long about it. So question 1, remember, work is equal to force times distance, and the force is equal to the mass times gravity. All right, that's what we're trying to solve. That's what you're solving this, but you have to do some of that little work ahead of time. Okay, if you hold the back, all right, this is what I sent an email, or I sent an announcement on, because I got several of you said, hey, wait a minute. And I just talked to another one of your classmates about an earlier problem about if you're in deep, dark space and where there's no gravity, what is your mass? Or what's your weight? And he said, well, you can't determine that because there's no gravity. I said, well, you can determine that. It's 0. You got to get used to the fact that if something is, well, so I gave away the answer to that, but anyway, but I think it's important that we talk about that. If you have 0 as your answer, then that's determined. You can put a number on it. All right. If you hold the box over your head, how many joules of mechanical energy are you expending? In other words, how much work are you doing? Force, you're applying a force, but is it moving? Have you moved at a distance? No. When you got it up to that certain height, you moved at a distance. So that would be 0. All right, if you raise the box 22 meters in 1.5 seconds, what is your power? All right, and one of your classmates, I think, I'm hoping she got it because she sent me an email saying, I'm having trouble with this power thing. And I said, well, come on in. Didn't see her. Still in the class and doing well, so I guess she figured it out. But anyway, so here you go. Oh, you got to be able to see it. So question number 3, remember, did the work, which is the force times the distance, and you did that up here, but power is equal to the work divided by the time, the change in time, how fast you did the work. That's what power is. Okay? What is base jumping? We talked about that. A wingsuit athlete. Now, I think, did I say 2 to 1 in the last one? I'm going to tell you right now the answer is 3 to 1. They can go 3 feet sideways for every 1 foot down. I think I kind of harped on 2 to 1, so I'm going to just tell you this one right now. Boom. It's 3 to 1. Okay? They go 3 feet sideways for every 1 foot they go down. All right? All right, so here we go. The next one, and then I'm going to stop this. So 4 is just a basic definition. 5, I told you the answer. A hockey player is on a very large. Okay, so let's do 6. 5. I'm just going to put 3 to 1 here on my thing, and let's just look at 6. All right. If the puck was pushed, 6. A hockey player on a very large lake, he smacks a slap shot at 106 miles per hour. Calculate the change in kinetic energy of the puck. The puck has a mass of 0.17 kilograms. We're assuming the puck was at rest before it was hit. Okay, so the change in kinetic energy is just the final kinetic energy of the thing. All right, so here's what we do. The kinetic energy, or the change in kinetic energy, is equal to the final kinetic energy minus the initial kinetic energy, which was 0 if it was just sitting there. And kinetic energy we know is 1/2 mv squared. Now, first thing you got to do is take 106 miles per hour and convert that to meters per second. First thing you got to do, okay? Let's take a look at one more problem, then we'll stop here and we'll move on and we'll do another. If the puck was pushed by the stick 0.7, how much force did it withstand? Oh, okay, well that's fun too. Once again, the work done is equal to the force times distance, which equals my change in kinetic energy, which we got up here, okay, which we got from answer 6. Following? So the distance was equal to 4 centimeters. Now be careful with that. 4 centimeters, be careful, because that distance then is 0.04 meters. So I'll tell you that one. Okay? So the force is going to equal your change in kinetic energy that you got in problem 6 divided by this distance. All right. See, these are not easy, especially if you had to do them by yourself. I mean, they're just, they'd be way beyond the scope of this course, but I'm just wanting you to see what it looks like to be doing physics, not to show off that, oh, I know how to do this. Just to show that you all that are to show my sports students that you guys are capable of doing this too. You know, I know most of you know you're capable of doing it, but it's just reassuring. You're like, oh, I can do story problems. Yes, you can do story problems. All right, so we'll stop here.